All right, let's just jump right in. Look, if you've ever written a line of code, you know this feeling. You're staring at the screen, your code's blowing up, and after way too much time you realize you just used the wrong kind of container for your data. It's such a common tripwire, but we're going to fix that right now.
Seriously, it can feel like one of those spot the difference puzzles, right? You've got an array, a list, an object, and they all kind of seem to do the same thing. They hold stuff. But, and this is a big but, mixing them up is a one-way ticket to some really frustrating bugs and honestly, just clunky code.
But hey, that's what we're here for. We are going to totally demystify these things. We'll look at the unique superpowers of each one so you can walk away knowing exactly which tool to grab from your tool belt for any situation.
Okay, first up to the plate, the array. This is the OG, the foundation of so much. And the best analogy, the one that I think makes it click instantly, is to just picture a really, really organized bookshelf. So what is it, really? An array is an ordered collection of items, but it's got a couple of strict rules you got to remember. It usually has a fixed size. You can't just add more space, and all the items inside are typically the same type. Let's unpack that a little. When we say ordered and indexed, it just means everything has its own numbered spot, its own address, starting from 0. This is key because it makes grabbing something incredibly fast. Then you have fixed size. Just like our bookshelf, you have a set number of slots, period. You can't just magically create a new one. And homogeneous? Well, that just means all the slots are built for the same kind of thing, like a shelf dedicated only to paperbacks.
And you can see that efficiency right here in the code. We've got an array of student scores. If we want that third score, we don't have to search. We just say, hey, give me what's at index 2. And boom, we get 76. It's instant. Super direct, super fast.
So when is an array your go-to? Think about any time you know exactly how many items you're going to have right from the get-go. Like the months in a year, or maybe all the pixels on a screen for a game board. They're absolute workhorses for numerical data, and anytime you need that lightning-fast access just by knowing an item's position.
Okay, but what happens when you don't know how many items you'll need? What if your collection needs to be, a bit more stretchy? Well, for that, we need something way more flexible. So let's talk about lists.
Right, so if an array is that rigid bookshelf, I want you to think of a list as your shopping cart. It's still an ordered collection. Things stay in the order you put them in, but it has one massive advantage. It's completely dynamic.
And that dynamic nature is its true superpower. You can just keep adding stuff or taking stuff out, and the list just grows and shrinks to fit, no problem. Now, it's still ordered, it's still indexed just like an array. In fact, under the hood, a lot of languages build lists on top of arrays. But the key difference is they completely shatter that fixed size limitation.
And check out how simple this is in practice. We've got our shopping list. We decide we need cereal. We just append it. That's it. We can even remove things just as easily. The list just handles it, adapts on the fly, no complaints, no fuss.
So where do lists really shine? Well, pretty much any time you have no idea how big your collection is going to get. That shopping cart is the classic example, right? Or think about a to-do list, or maybe a history of a user's actions. If you need flexibility, a list is almost always going to be your best friend.
All right, so we've talked a lot about ordered sequences. But what if the order is totally irrelevant? What if your main goal isn't to list things, but to describe a single thing? That, my friends, is where objects come in.
Yeah, so with objects, just forget about numbered slots. An object is more like a profile page, or maybe a business card. It's a collection of key value pairs. And what that means is that every single piece of data, the value, gets its own descriptive label, the key.
And this brings us to the core concept, keyed access. You're no longer asking, hey, what's that position to? Instead, you're asking, hey, what's this person's age, or what's their occupation? The order is meaningless. It's all about the labels. And this lets you build these rich, descriptive structures that actually make sense to a human. Take a look at this example. It's an object for a user profile. You can see the keys right there: name, age, occupation, and each one has its value. If I want to get the name, I'm not looking for index 0. Nope. I just ask for userprofile.name. It's so much more intuitive, it practically reads like plain English.
So objects are perfect anytime you're trying to model a single entity that has a bunch of different properties. A user, a product, a car, anything like that. They're also amazing for things like configuration files or for making sense of all that complex JSON data you get back from an API.
Okay, we've met our 3 contenders. Now it's time for the final showdown.
Let's put them side by side and really hammer home the differences. This table really lays it all out, doesn't it? You can see that clear line in the sand. Arrays and lists, they're all about ordered sequences. Objects, they're all about those key value pairs. Size, arrays are typically fixed, while the other two are dynamic. And the big one, access, by index for the first two, by key for the last one. And those analogies just tie it all together, right? The rigid bookshelf, the flexible shopping cart, and the descriptive profile.
Look, if you only remember one thing from all of this, make it this right here. Indexed access, for arrays and lists, is all about asking, what's at position X? Keyed access, for objects, is about asking, what is the value of Y? That is the fundamental choice, the fork in the road you have to take every time you store data.
So, what does this all mean for you? How do we take all this theory and turn it into practice? How do we get you coding with total confidence?
Honestly, it boils down to a super simple 3-point checklist. Next time you need to store some data, just stop for a second and ask yourself these questions. 1. Do I need an ordered sequence, and do I know the size ahead of time? If yes, use an array. 2. Do I need an ordered sequence, but it has to be flexible? That's a list. And 3. Am I trying to describe one single thing with a bunch of named properties? That's your cue to use an object.
And at the end of the day, getting this right isn't just about acing a technical interview. It's about writing code that's cleaner, way more efficient, and just easier for you and everyone else to read. It really is all about choosing the right tool for the job.
So I'll leave you with a question to think about. Which one of these was the one that always tripped you up? And more importantly, now that it's all laid out, what's the first piece of code you're thinking about changing or building differently because of it?